For our final topic in both this section and our series of sections on data visualization, I want to talk a little bit about spatial data, data based on space. So we're going to look at an example that uses geographic information systems, GIS. In our social sciences department, we have a faculty member, Renato Cardania. I'm not sure I spelled his name right, by the way, but Renato is an expert in GIS. So if you're curious about more GIS, let me know and I'll refer you to him. But just so you know, there's a nice gaming example, which was actually, I couldn't find any good data sources, but kind of motivated this last discussion. In video games, you could imagine, just think about a game where you've got a character that walks around an environment and engages in contests with other non-player characters. Maybe they fight enemies or whatever. You could look at where the character is in the environment and how likely it is they are to succeed in a given contest, controlling for lots of other things like the skill level and the weapons they use and things like that. And so you could assign these percentages, these loss ratios, to various points in the map of your environment and to see if there's any weaknesses or if you need to make any changes in the nature of in that portion of the game in order to try to equalize things, or maybe you want it to be that way. So here's an example of GIS data. What we have is a number of health clinics across the state of Michigan. There's over 1,300 different clinics in this database. We've got kind of what kind of a health facility they are, what's their name, their street address, their city, their state, and other such data. So as we look at this, they've got some kind of facility type. So these are code, right? So this is a big data table. And how might you visualize it? Well, since we've got addresses, the natural way to visualize this data is through a map. And this is what geographic information systems does. So if you take a look at this map, you can see health centers clustered around our major population areas. Detroit over here in the lower right, Grand Rapids, Kalamazoo down here. And you see in Lansing is another cluster, Flint, Ann Arbor is kind of sucked in with Detroit. But in the northern Michigan and in the UP, you see it's much less dense because the population is much less dense. We could zoom in on Big Rapids. That's another nice thing. See, I'm just dragging and using my mouse to zoom in. And you see here in Big Rapids, where I'm located at Ferris, there's a very small number. And for those of you familiar with the area, the major one, our major healthcare provider is Spectrum Health, right, which serves all of Mecosta County. One could, from this data, extract, if you got the population for each zip code, one could come up with densities. So the zip codes in the data set, right? So one could come up with the population in each zip code and figure out how many healthcare centers are there per person and plot those on a map with different colors. You could also look at things like capacity. Now, for some reason, this seems to be empty here. I think this is part of a larger database where these are non-zero matters. But you could use capacity as a way of looking at healthcare availability, and you could look at, for example, number of beds per person in a given zip code, which would be very useful in a pandemic, especially if you plotted them across the state. As we saw in the last video, you could use things like different bubbles or different sizes to represent different ranges of densities. In the next chapter, we're going to look closely, we're going to look a little closely at defining variables and some of the challenges in defining observable and measurable data variables.